Hi everybody, welcome to our 11.2 notes. For 11.2 we're going to be solving quadratic equations using another method which is called completing the square. The great thing about completing the square is it works all the time for every quadratic you're going to get. Okay? So just to kind of put a little bit of framework in there for you. X squared plus 6x plus 7 equals 0. Could we use the factoring method to solve it? Unfortunately, no. It doesn't factor. If you tried to factor it, you'd probably do x plus 7 and x plus 1, which would give you a middle term of 8x and not 6x. So that one actually doesn't factor at all, so we can't use the factoring method. How about the square root property? Could we use that? Not really, because we couldn't get a square by itself. You know, we could get x squared by itself, but then we'd have an x on the other side. And that's not really solving it, right? So not really. So we need another method. So the other method that we're going to learn today is called completing the square. The main idea behind completing the square is, if you guys kind of go back in your notes to the 11.1 example 3 notes, this format of x minus 4 squared equals 3, or p minus 5 squared equals 40, something like that, we could solve those, which was great. And so with completing the square, we're actually trying to get them into the format, okay, of a perfect square trinomial, to get it into something that looks more like x minus 4 squared or p minus 5 squared. We're trying to get it in that format so that we can solve it. So the question is, how do we get it into that format? Okay, so we're going to look at just perfect square trinomials first. We're going to factor them, and then we're going to look at some patterns. Okay, so first one I have is x squared minus 10x plus 25. If you wanted to factor that, we'd probably do guess and check factoring. The first times the first should give us x squared, so x times x. The last times the last should give us positive 25. So with it being positive, I know that my signs are the same. Looking at the middle term with it being a minus, I know that my signs are going to be minus and minus. Then to get to 25, I could either do 5 times 5, or I could do 25 times 1. But the only one that's going to give me a 10 in the middle is 5 times 5. And just double checking, negative 5x plus negative 5x is negative 10x, so it's factored correctly. What you'll notice is that we have two of the same parentheses. So x minus 5 times x minus 5, which is x minus 5 squared. Okay, let's look at another one. We've got y squared plus 20y plus 100. Same idea. If I guess and check factor for this one, the first times the first should give me y squared, so y times y. The last times the last should give me positive 100. So with it being positive, I've got the same sign. Looking at the middle term with it being plus, that's going to be my sign. It's going to be y plus and y plus. And then to get 100, there are a lot of different options. But the only way I'm getting 20 from all of those options would be 10 times 10. So 10 times 10 gives me 100. 10y plus 10y gives me 20y. Okay? And yet again, you notice we have the same parentheses twice. Okay? So that's y plus 10 squared. One more. I know it has a fraction in it, but we can still factor it. We'll have z squared plus z plus 1/4. And if you were guess and check factoring with this one, first times the first should give us z squared. So that would be z times. The last times the last is going to give us 1/4. It is positive, and the middle is plus, so my signs are going to be plus and plus. And to get 1/4, let's try 1/2 times 1/2, because 1/2 times 1/2 equals 1/4. And just checking ourselves here, 1/2 z plus 1/2 z is 1z, which is our middle term. And again, you notice we have the same parentheses twice, so this is the same as z plus 1/2 squared. So the question is, how do we know that these are perfect square trinomials? What do they always look like? Well, with the perfect square trinomials, you always have a perfect square at the beginning. You always have a perfect square at the end. And if you take the square root of both of those things, multiply them together, and multiply it by 2, that's when you get the middle. So they're always in this format of like a squared, it may be a plus or it may be a minus depending on your problem. 2ab plus b squared. And then that's going to factor as a, then that same sign as the middle, plus minus b squared. That's the format that it always comes in. So really what we're doing from here is I make one of those so that it's a perfect square trinomial, so then I can factor it and it's going to be a nice pretty square, so then I can use the square root property, because that would be great. Okay? So what we're going to do is complete the square for each one of these. So first one I have is x squared plus 4x plus, and then we need to figure out what goes in the blank so that it's a perfect square trinomial. Okay? So if it helps, that 4x, that's your 2ab. Okay? So I know that the x comes from the square root of x. The 4 is going to come from 2b. Okay? So if that kind of helps a little bit, 4 equals 2 times b. Okay? So that means that b, if I divide that middle term by 2, b would be 2. And then it means my last term, I would just square it. Okay? So if I square it and square it, 2 squared would be 4. So what you're doing is you're taking the middle term, dividing by 2, and then squaring it. That's what you add to make it a perfect square. Okay, let's try another one. We have t squared minus 2t plus blank. I want to figure out how do I complete the square here. So I'm going to take my middle term, which is negative 2t. I know the t comes from the t squared, so I'm really just looking at the number here. And I'm going to take negative 2, I'm going to divide by 2, and then I'm going to square it. Okay, negative 2 divided by 2 is negative 1, and negative 1 squared, so that's negative 1 times negative 1 is positive 1. In case you're curious, you're always going to add positive values at the end to complete your square. Okay, one more. In part C, we've got x squared minus 5x plus blank. You guys are going to learn to love even numbers and be a little meh about odd numbers, but we can still do it. So we're going to take that middle term, and again, that x comes from the x squared, but we're just looking at the minus 5. So we're doing negative 5, we're going to divide by 2, and then we're going to square it. And unfortunately, negative 5 does not divide by 2, so we're going to have a fraction. So if I square it, I'm going to have negative 5 times negative 5, which would be 25. And 2 squared, which would be 2 times 2, which is 4. So that's how you complete the square. And once you complete the square, what you can do is factor it, just like we did in these factoring review up above. And then it's going to look just like what we had in 11.1. Okay? One thing you also might notice, for all of these, I just had a regular x squared, regular t squared, or a regular y squared. I didn't have a coefficient in front, and that was purposeful. Okay? That's to make it a whole lot easier on you to complete the square. Okay? So steps to complete there. If you have an a value, so if you have a coefficient in front of your x squared or your t squared or your y squared, whichever term is squared, go ahead and divide by that at the very, very, very beginning. Okay? Make sure that everything's on one side. Okay? And then what you're going to do is move the constant to the other side so that it just doesn't get in your way. Okay? So then what you're going to do is complete the square. So we talked about taking that b value, divided by 2, and then squaring it. And adding that to both sides. Okay, because of course it's a equation, so whatever you do to one side, you've got to do to both. Okay? And then you're going to write that left-hand side as a binomial squared. In other words, we're going to factor it. Okay? And then you can take your square roots and you can solve it. Okay, so let's do that. first one I have in example 2a is x squared plus 6x plus 7 equals 0. Good news, it's just a regular x squared, so I don't even have to divide the beginning. I'm ready to go. Okay? So then I'm going to set it up for completing the square. What that's going to look like is I'm still going to have the x squared, still going to have the plus 6x, and then I'm going to have a plus blank here because I want to complete the square. Then I'm going to move the 7 over just so it gets out of the way. So I'm going to subtract 7 from both sides, like that. Now I'm set up for completing the square. To complete the square, I'm going to take that middle term. So remember, the x comes from the x squared. Really, I'm just looking at the 6. I'm going to take the 6 and divide it by 2, which would be 3. Square it, which would be 9. And whatever I add to one side, I have to add to both sides. Okay? So this is the completing the square part. After that, we can factor it, and it factors really, really nicely, okay? So this is going to be x times x and 3 times 3. So we're going to have x plus 3 squared, okay? So in the squaring part, it's always the square root of the first one, the square root of the last term, and it's the same sign as the middle, okay? On the other side, negative 7 plus 9 is 2. And then, at this point, you can say, oh, good. It looks just like 11.1, and so you can do it the same way as we did it in section 11.1, which would be, let's take the square root of both sides. And don't forget to do the plus or minus square root. Don't forget half your answers, okay? So on the left side, the squaring and square rooting cancel out. So that's x plus 3. On the right side, don't forget your plus or minus, please. We got plus or minus the square root of 2. And then to get x by itself, all I need to do is get rid of plus 3, so that I would subtract 3 from both sides. So x would equal negative 3 plus or minus the square root of 2. And that would be my answer. Okay. Let's try some more, okay? So in part B, I've got x squared plus 4x equals 1. We are actually pretty well set up to do some completing the square at the beginning. The x squared has just a coefficient of 1. We're ready to go. We've actually already moved the constant over, so let's get started. To complete the square, I'm going to have an x squared. I'm going to have my middle term, which is plus 4x. And I'm going to leave a blank for when I complete the square. Equals, on the right side I have a 1. Okay, so let's complete the square. So I'm going to take my middle term, which is my 4x. I know that my x comes from the x squared, so really I'm focusing on the 4. I'm going to take that middle term, which is 4, divided by 2, which would be 2, and then square it. 2 times 2 would be 4. Okay, so you're taking the middle term, the 4, you're dividing it by 2, and then you're squaring that, okay, to get to here. Then we're ready to factor it. So remember, factoring, the square root of x would be x. My sign is going to be the same as the middle. The square root of 4 is 2. So the set factors is x plus 2 squared. That's x plus 2 times x plus 2, and if it helps you, 2x times 2x is 4x, okay? Now if I added 4 to this side, don't forget, we should add 4 to the other side too. So now I've got x plus 2 squared equals 1 plus 4, which is 5. Okay. And again, at this point, you can say, oh good, it looks like 11.1. Hopefully you guys are feeling comfortable and confident at this point. Okay. From here, let's take the square root of both sides to get rid of that squaring part, okay? So square root, and take the square root. The square root and the squaring are going to undo each other on the left side. You'll be left with x plus 2. On the right side, don't forget that it's plus or minus, positive or negative, square root of 5. And last but not least, to get x by itself, we will subtract 2 from both sides. So x would equal negative 2 plus or minus the square root of 5.